Hey fans, Fanreal here again. This time I'm going to be showing you a little work in progress cab that I have going on right now. This is the Brooklyn Union elevated car, the BU gate car cab. I've managed to work in the basic cab texture and also a working brake gauge. This cab is off of a convertible car number 1349 up at Brantford, and basically the only thing that really needs to be done, that's left to be done on this cab, is to animate the power handle, the master controller, and the brake handle. So this is just me a quick demonstration. Gonna run through a cycle of the brakes just to show you that the gauge works and to preview the compressor sound for this train. Other than that, there's really not much in ways of progress for this train that's been, worked on. But we're working on it, so hopefully we could get this train out as a full set, maybe sometime in the late spring to early summer of 2018. Alright, without further ado, let's run through these tests. I'm going to pull up that the in-game brake status so we can show you, so I can show you exactly what the train is actually doing as I'm doing the brake tests. Alright, so there's the compressor cycle. So basically the main reservoir charges up to 100, and then the compressor doesn't kick on until the main reservoir pressure drops to below 85. But it definitely kicks in before 80. So the brakes on this car are going to work pretty much the same way as they do on the R9 in BVE, since there's only one form of manual lap braking for this game. In real life, the brake setup is slightly different, and I can go through that explanation as we're testing out the brakes. So as with the R9, the gauge reads the red needle is your main reservoir pressure, and the black needle is going to be your train line or your brake pipe, whichever one you want to call it. It's going to function the same way regardless of whether or not it's on the gate car or the R9 in the game. So 70 pounds on your train line is going to be full release. And as you take a reduction, the typical multiplication values follow. 2.5 pounds of air in the brake cylinder for every pound out of the train line. So you're going to equalize at 50 pounds in the train line is 50 pounds in the brake pipe, in the brake cylinder, meaning you have full surface application. So here we go. Take a full reduction. Alright, as you can see, train line is at 50, brake cylinder is at full pressure. So that works. If I take a half reduction to 60 pounds in the train line, that should be halfway up on the brake cylinder or so. Alright, a little less than half. You're going to notice that I have in this setup the typical 3-car formation. We got a motor car in the front and the rear and a trailer in the middle. The trailer does not have air, air tanks or compressors. so it's being supplied with the air from either motor cars. So you're going to notice a little lag in the brake cylinder because there are no electric brakes on this train. Alright, so here's the tricky part in BVE. It does not apply to real life, but in BVE, for some reason, when you go to release a manual lap brake, it does not equalize the way it should. So say in real life, if I were to bail off now from 50 pounds in the train line to 60 pounds, the brake cylinder pressure should fall to halfway. Doesn't actually do this in BVE for whatever reason, so let's demo that. So BVE, basically there's no graduated release. In BVE does not graduate your release in manual lap equipment. It's a direct release only, which makes it problematic when you're operating, because if you're trying to go from full service brake to a half brake, you're gonna have to do some fancy brake manipulations. So we'll do a full release again. It doesn't let me hold the Alt key and release at the same time. Alright, so it's the compressor on the rear car turning on. So basically what you want to do if you're coming into a station hot is you want to take a full brake, like so, and if you find that you're stopping too quickly, you want to bail off. You do quick, very, very quick manipulations from service to lap. Like literally a quarter of a second in lap and back to in release to lap. Release to lap will release your brakes partially. But then the issue with that is if you bail off too much brake cylinder air and you need to reapply, now you're at the train line is at like 52.5, and you're not really going to get that much more brake pressure by going back to 50. Sometimes that won't be enough. So if you're going to adjust the brakes like that, it's basically a very quick combination of lap to release to lap and then back to service. So usually what I like to do is I'll take the full service. So let's try that again. So we're going to take a full service again. And then now what I like to do is if I'm coming in too hot, I'll bail off I'll bail off about 5 to 8 pounds. That didn't work very well. Let me just do this to demo, and maybe I'll get it. Yeah, so basically, like, what I'll do is I'll fully release, I'll bail off 15 pounds or so on the train line air, which fully releases the brake cylinder, but that way, when I reapply from 65 pounds to 50 pounds, I get at least a half brake in the brake cylinder. So when you're running with manual lap equipment in BVE, that's basically what you have to do to graduate your brake release. So the strategy that I use to perform a station stop is I'll take a full service and slow the train down from, let's say I come in at 40 miles an hour, I'll slow the train down to about maybe 20 miles an hour or 15 miles an hour. I'll do the bail off. I'll bail either 10 to 15 pounds off. So by the time the train's at 15, I'm at like between the 6 and 8 car marker. That way when I bail off, and reapply, I'm now at the 8 car marker doing about maybe 10 to 15 with half brake. That brings me to a stop at the 10 car marker with the half brake. So that's basically how that works. Let me see if I could demo this. Alright, so I've moved a little further down the line for this demonstration. So what we're going to do is we're going to take this BU train down one stop down this downhill, and we're going to try to make this station stop using the method I detailed a few moments ago. After that, I will go through how the actual controls on the BU work between the brake handle and the master controller. So without further ado, let's proceed. So you're going to notice that the BU only has 2 points of power. You have full series and full parallel. I'll get more into that as we go further down the line to the next station. Also, you're going to notice that the BU has a relatively slow rate of acceleration and a relatively low balancing speed, around 35 to maybe 38 miles an hour max on level track. This is because the cars themselves were slightly underpowered. They did tow trailers as well, so I've made sure that they balance pretty slowly. So let's see if we can make this stop. Alright, there's your full service brake reduction. And there's your graduated release. So as you noticed when I made that graduation with the direct release brakes, I bailed off to about maybe 62, and then I reapplied to 50, which completely released my brake cylinder and then brought it back up to about a little over 1/3 braking. We're able to stop within 5 meters of the actual station marker, so that's okay. The brakes on this train are also a little weak. I've made it that way because of some documentation that I came across regarding the specifications of these cars. I could always up the brake rate at a later time before this train actually gets released if I see fit to do so. Alright, so now that we're in the station, let's go through the actual brake setup on this train. Alright, so this is your brake handle and your brake valve setup on the BUs. You're going to notice that this setup is a little different from your R9 setup because this schedule of braking is actually older than the R9s, of course. And it's known not as AMUE brake as it is on the R9 and the low Vs, but it's known as an AML brakes schedule. AML. So the notches on this setup are a little different. Of course, the position that you see the brake handle in right now, that is your full release position, all the way to the left. This position is self-explanatory, so I really won't explain much about it. Now, if we go over to the right 2 positions, to that middle position that's facing you, the viewer, that is your lap position. That's the position that the brake handle would be in right now if it was animated. With the stock of the brake handle pointing directly at your face. That position is where the openings in the brake valve overlap. Better yet to say, the closed part of the brake valve is overlapped, so that you don't have any air entering the brake system. You also don't have any air venting out from the brake system. So that position obviously is used to hold your brake application, should you actually have one. The next position over from lap is your apply position. That cracks open the train line air, and it equalizes down into the brake cylinder, giving you your brake application. Position over to the right of apply, obviously all the way to the right, that's your emergency position that vents your brake air, your train line air into the atmosphere and gives you emergency brakes. Alright, so the main difference between AML and AMUE braking here is your notch that you have between your full release and your lap. So if you look at the middle notch and you move one over, that notch is known as your graduated release notch. This notch basically is there to provide a slower rate of release than full release, which allows for better train handling. So say you're at a full service brake, 50 pounds in the brake cylinder, and you wanted to bail off 10 pounds in the brake cylinder. What you would basically do is you would move the brake handle from your lap position into the graduated release position, and using that position you would bleed off the 10 pounds from the brake cylinder, and then once your bail was complete, you would move the brake handle back into the lap position. Now, the purpose of having this graduated release position, where it is, obviously, is you can see that it's right next to the lap position. So the amount of handle movement that you need to get from the lap to the graduated release is very small, which allows you to quickly go back and forth between the positions and bail off the tiny amount of air, as much tiny amount of air as you need, as slowly as you need it. Alright. So let's move on over to the master controller. Alright, so you can see that this controller has two different zones. So the position that the controller is in now is off/safety. In this vertical position, the emergency brakes are tripped. The air does not actually, you cannot actually run the train with the controller in this middle position. Your emergency brakes will be applied, and you cannot charge the brake. Now, as you move the controller in either direction, to the left or right, that selects your direction of running. If you move it to the right, the train proceeds forward. If you move the controller to the left, the train proceeds in reverse. Now, as you can see to the left of the actual controller, there's going to be a little notch right there that disappears behind the control stalk. That is present on either side of the middle line here, and that denotes your barrier between the zone of directional operation and the safety, the middle safety notch. When you're operating a BU car, you basically have to hold the black button. You push it in. That basically engages a lockout lever that you see behind the yellow knob. It pushes forward, and that way when you're in either zone of direction, if you bring the train back to coast, that little knob that's pushed forward hits that center post behind the that sticks up out of the body of the control stand and prevents the controller from inadvertently going into the safety position and dumping the train. So now, going left, that entire zone between that little notch that disappears behind the control stalk and that first giant notch to the left here, that entire position on either side of the safety zone, that is coast. you can jiggle the controller within that zone as much as you want. The train is not going to take power. It's not going to go anywhere. That entire zone is coast. So as soon as you move past that first notch on either side, first large notch on either side, I should say, you're now in full series. The full series is anywhere between that first giant notch to the left or right of the controller and that second giant notch before the two posts on the far ends. That is full series. As soon as you move past the second notch, between the second notch and the giant posts, that's full parallel. So that's how the controllers on these cars work. Obviously, this is sort of, I don't know if it's correct to classify this as a low voltage type of controller, because the actual cam drum is not in the controller. Obviously, it's underneath the car. Now, whereas say on a Hy-Vee car, like a deck roof or a Gibbs Hy-Vee, the actual controller in the motorman's cab is a high voltage controller. You have 600 volts going through there. I'm not sure as to the specifics of how the gate car controller works, but being that there's only a full series and a full parallel notch with automatic acceleration underneath the car, it leads me to believe that this may or may not be some type of low voltage control, possibly, because there are batteries on this car. So obviously, like I said before, you only have two notches on the controller, full series, full parallel, but underneath the car, the cam drum does spin up from series 1, 2, 3, 4, and parallel 1, 2, 3, etc., etc., etc. So the car does have automatically timed acceleration. It's pneumatically driven, it's air driven. So when you take a point of power on these cars, you will actually hear the an air sound start up, like psst, and when you shut off, it sounds like this. Psst. That's the sound of the pneumatically driven cam drum underneath the car, rotating through the points of power. Alright, so that concludes this demonstration of the new low-V cab and the air brake system on basically the R9 not the low-V cab, excuse me, the gate car cab. So this concludes the demonstration on the gate car cab, excuse me, and basically also is a tutorial of how to work the brakes on the low-V, the R9s, and the gate cars. So let me zoom back out. So, I just want to thank you guys for watching. Do stay tuned. I hope to get these brake handles and power handles animated on both the gate car cab and the low-V cab sometime in the coming months. And hopefully we'll have by then exteriors to pair these cabs with that are decent. So, thanks for watching. Once again, Merry Christmas, Happy New Year. Hope you all are enjoying your time off from school, or hopefully you have off from work. Enjoying the holidays with family, whatnot. But yeah, so do stay tuned for more updates in the near future. And until next time, see ya.